All right, so now we are going to look at some examples. So example 1, first we're going to list the transformations. And so starting in order, we have a vertical compression by 1/3. We have a right 7 and an up 6. Now, when in doubt, sketch it out. I always sketch it out. So because there are no reflections, I know this function is still going up and to the right, just like the parent function. And then the starting point, which was at 0, 0, has been moved right 7, up 6. And so the new starting point is 7, 6. And this picture is really going to help us with the domain and range. It's starting at 7 in the x and going to the right. And so 7 with a bracket to infinity parenthesis. For the range, it's starting at 6 and going up. And so 6 to positive infinity. 6 gets a bracket, infinity gets in a parentheses. And so that's where the direction is helping us. It's going to the right, that helps us with domain. It's going up, that helps us with the range. And so this function, without any interval cutting it off, has a minimum. That minimum is this starting point at 6. And so it's important to note that this number, and this number are the same. Your y values are going to be the same. And then here, this number and this number will always be the same. Okay, example 2, this is bad form, so the first thing you're going to do is put it in good form. And so we need to factor out this -2, but leave it under the radical. We just have an extra set of parentheses. So if we divide this number by the -2, it turns into a -1/2. And then we still have that -7 clearly outside. And so when we list our transformations, start with this negative inside. We know that's Ry, followed by an HC, horizontal compression, by 1/2, followed by a right 1/2, followed by a down 7. Now, because this function has been reflected across the y-axis, it's still going up, but now it's going left. So left and up. That's what an Ry does. And so because it's been moved right 1/2 and down 7, that's our new starting point. And so our domain ends up getting flipped, and it is going from negative infinity to 1/2. The 1/2 still gets the bracket. It's tempting to say 1/2 to negative infinity, but remember, we always go in order from left to right, and so negative infinity always has to be your left endpoint. And so we say it's going from negative infinity to 1/2. That will be counted wrong if you put it in the wrong order. For the range, it's still starting at -7 and going up to positive infinity. So bracket -7 to positive infinity. And so we still have a minimum because it's still going up, and that minimum is -7. Remember, this, and this will always match. Okay, example 3. We have nothing in front of the x to factor out, and so we have one transformation, which is our Rx, a vertical stretch by 4, no left or right. This -7 is outside the radical, so that is down 7. Okay, and so the Rx flips Squidward, our parent function, down, but he's still to the right. Oh, they don't ask for direction here. Don't write that. Okay, and so our starting point just moved down 7, and so it's still 0 at -7. And so for our domain, we are still greater than the 0 because it's going to the right. So 0 to infinity, because it's going to the right from 0. For the range, we're starting at -7, but this time it's going down. And so this is where we're going to have negative infinity to -7 bracket. Okay, and so now we are bringing back the interval. Okay, and so remember, these are x values. They are restricting the domain here. And so I am going to erase this and redraw the graph on that interval. Okay, so the interval from x equals 2 to x equals 6. And so let me get some axes. And so because this function's been moved down 7, I'm going to make sure I give myself plenty of room to go down 7. Okay, and then our interval is going from 2 to 6. So 1, 2, 3, 4, 5, 6. And so first I'm going to graph the function. So down 7 puts the starting point there. And then the Rx means he's upside down, but still going to the right. Okay, and so that's as accurate as you have to be. You just have to know the direction and the starting point. And so now when I put the interval on the graph from 2 to 6, we can identify where the max and min are going to be. So the max and the min. And so this function, the y value here is higher than the y value here because this function is decreasing as you go to the right. And so this is going to be our maximum because max refers to y values. And then this is going to be our minimum. Okay, so I have to plug in x equals 2 and x equals 6 to get those max and min values. And these aren't going to be pretty because we're dealing with square root here. And so I'm going to zoom in so I have plenty of room. And so when I plug in x equals 2 into this function, I get -4 square root of 2 minus 7. And you will need to simplify radicals. Here you can't simplify square root of 2, so that's as simple as it gets. Okay, because square root of 2 is not a rational number, you're not going to be able to write it any nicer way without getting a decimal that is an ugly decimal. And so we're going to have you leave your answer just like this. Okay, and so that is the maximum, -4 square root 2 minus 7. On Canvas, you would type -4 SQRT of 2. That's where your parentheses go. And then you would put a -7 outside the parentheses. For the minimum, we're plugging the x equals 6. And so into that rule, we would have -4 square root of 6 minus 7. Okay, 6 breaks into 2 and 3. Nothing pairs up, so this square root can't be simplified. And so for the min, we would have -4 square root of 6 minus 7. And that's as pretty as you're going to be able to write this answer. So on Canvas, you would type -4 SQRT of 6, close parentheses, minus 7. Okay, example 4. We have another Rx. And then this is bad form. So I have to add parentheses and divide this -2 by this 1/2. Remember, dividing by 1/2 is the same as multiplying by 2. And so in good form, we would have 1/2 x minus 4. If I were to redistribute 1/2 times 4, I'd get that 2 again. And so we have the Rx, we have the horizontal stretch by 2, and then we have our right 4. Okay, so on a graph, first let's look at what intervals we're interested in. 0 to 8. Okay, and then, so I'm going to do this. Let me get black. One, 2, 3, 4, 5, 6, 7, 8. And so our function has been moved right 4, but not up or down. So 1, 2, 3, 4 for the starting point. And then because of the Rx, it is now down. So our domain goes from that 4 to positive infinity because it's still going to the right, whereas the range is negative infinity to 0. We are less than the 0 now for the y, for the range. All right, so for our max and min, if we are looking at the interval 0 to 8, 0 is over here, 8 is over here. And so the question I always get is, do we actually have to draw the picture? And the answer is yes, because if you just start plugging in this interval, you're going to get an error and you're going to think it doesn't exist. But if you look at the picture, we have a maximum right here on the graph. It's at the 0. And so with your picture, you don't have to plug in anything. You see that the global maximum of this function, if the starting point lands on this interval, it's automatically your max or your min, depending on which way your function is facing. And so the maximum is 0, type that in, move on with your day. Okay, the minimum, I'm switching colors. The minimum happens right here. Okay, this y value is lower than this y value. Okay, it gets lower and lower. It's another decreasing function just like we had before. Okay, and so for the min, we have to plug in this 8. Okay, so going back to our function, you can go back to bad form just to plug it in if you want to. It's for, I'm going to zoom in again. We're plugging in x equals 8. And so negative square root of 1/2. And I'm going to stay with good form. 8 minus the 4 inside the parentheses, replacing this x with 8. Okay, that gives me negative square root of 1/2. 8 minus 4 is just 4. And 1/2 of 4 is 2. And so square root of 2 cannot be simplified anymore. So that's as nice as that's going to be. And so this was all for the min. And so on Canvas, if they're asking for the min, I would say negative square root of 2. And so you would type that as negative, then your SQRT, then your 2. That's exactly what you would type on Canvas for the minimum. If it was the maximum, you didn't even have to plug in the endpoint. It was 0. It landed right in between the x values they gave us. So just be very, very careful. You can't just randomly plug in these endpoints. You have to know where the starting point is in relationship to the interval.